Welcome back to our second explainer in the Python series. Today, we're going to build a really solid mental model for one of Python's most fundamental types, the string. And look, our goal here isn't just to memorize a bunch of commands. It's to really get why strings work the way they do. Once you get that, you'll be able to use them with confidence and, stop running into those common little bugs.
All right, so here's our game plan. We're going to kick things off by looking at how Python actually sees text. And spoiler, it's probably not how you see it. Then we'll hit the single most important idea about strings. They are immutable sequences. That's the core of everything. From there, we'll see how that idea controls how we read from a string, with indexing and slicing, and then we'll figure out what happens when you try to change something that's unchangeable, which always means creating something new. We'll look at a few common mistakes that people make and then wrap it all up with one golden rule for strings that'll make everything click.
So to really work with text, we've got to get on the same page as Python. You and I, we see a sentence, we see words, we see meaning. For a minute, we need to forget all that and try to see things the way the computer does.
So take a look at Hello World. To us, that's simple, right? It's two words, a greeting. But to Python, it's something way more fundamental, way more precise. And this is the first hurdle for a lot of beginners, thinking of it as just one single blob of text. The reality is, it's actually super structured and predictable.
And here's the key insight. Python sees this as a sequence. That word, sequence, is everything. It just means it's an ordered collection where every single item has a specific numbered spot, an index. For a string, the items are just the characters. So for Hello World, H is at position 0, E is at position 1, L at 2, another L at 3, and so on. And check this out. The space isn't just empty space. It's a character too. It has its own spot at position 5, then the W is at 6, and it just keeps going. Every single character, even punctuation, gets its own address. This idea of an ordered, indexed sequence, it is the foundation for absolutely everything else we're going to talk about.
Okay, so a string is a sequence. Got it. But now we need to add one more crucial word to that definition. You put these two ideas together, sequence and this new word, and you have the core mental model for Python strings.
All right, here it is. A Python string is an immutable sequence. We know what sequence means: ordered, indexed. The new word here is immutable, and this is the one you really have to get. It means that once a string is created, it can never ever be changed. It's locked in, it's permanent. Think of it like it's been carved in stone. Now that might sound kind of limiting, but it's actually a really smart design. It makes strings super predictable and safe to work with.
To really make this stick, let's use an analogy. Just think of a string as a page in a book that's already been printed and published. This isn't some draft in a word processor, it's the final, finished thing. And this book analogy is perfect because it explains everything, right? The text on the page is fixed. You can't just erase it. That's immutability. You can, however, point to a specific spot, like line 5, word 3. That's indexing. But what you can't do is take a pen, cross out a word, and write a new one on top of it. Python will stop you dead in your tracks if you try. So, how do you make a correction? Well, you do what you do in real life. You take out a brand new piece of paper, you copy the text, and you make your change on that new page. And that is exactly how Python works. You never change the original string, you just create a new, corrected one.
So if strings are locked down and can't be changed, what good are they? What can we actually do with them? Well, we can read from them with amazing precision, and Python gives us two main ways to do that: indexing for grabbing one character, and slicing for grabbing a whole chunk.
Okay, so every single character in a string actually has two addresses, or indices. The first kind, positive indices, are what you'd probably expect. They start from the left at 0. So in Python, P is at 0, Y is at 1, all the way to N at index 5. But here's where it gets really cool. Python also gives us negative indices. These count from the right, and they start at -1. So N is at -1, O is at -2, and so on. And this is super handy. Like, imagine you have a long file name, and you just want the file extension. Instead of figuring out how long the whole string is, you can just say, hey, give me the last 4 characters. It's a great shortcut.
So we just use square brackets to pull out any character we want. S0 gets you the first one, S-1 gets you the last one. Simple enough. But here's a heads up. If you ask for an index that doesn't exist, like asking for the 10th character in a 6-character string, Python's going to stop everything and give you an index error. Now that might feel like a pain, but it's actually a good thing. Python is protecting you. It's much better for the program to stop with a clear error than to just guess what you wanted and keep running with bad data.
Okay, Grabbing one character is cool, but what if we need a whole piece of the string, a substring? We can't just list out all the indices we want. No. For that, Python has a really powerful tool called slicing.
So the syntax looks like start, end. But here's the part that trips everyone up at first, that end number. The rule is simple. The slice includes the character at the start index, but it stops before it gets to the end index. Let's walk through it with Python and the slice s*(1 4. We start at index 1, so we grab the y. We keep going. We grab the character at index 2, that's t. We grab the character at index 3, that's h. Now we've reached index 4. The rule is stop before you get here, so we don't include the o at index 4, and our result is yth. It takes a little getting used to for sure, but once it clicks, you'll see this up to but not including pattern all over Python.
All right, let's circle back to our big rule, immutability. This is where having that mental model really starts to pay off. If you can't change strings, then what in the world is happening when you do something like add two strings together or call a method like .upper? The answer is always the same. You're creating a new string.
Okay, just a quick heads up on syntax, because you'll see two different styles. Sometimes you have a function like len that you wrap around the string. Think of this as asking a question about the string. Hey, what's the length of this thing? Then you have methods, which you call from the string with a dot, like myString.lower. This is more like giving a command to the string itself. Hey string, give me a lowercase copy of yourself.
Now this right here is probably the #1 mistake beginners make with strings. They'll write s.upper and just assume that the variable s has been changed. But it hasn't. Let's follow the breadcrumbs. First, you have your variable s. Think of it like a sticky note or a label that's stuck onto the string object hello. When you call s.upper, Python follows the rule. It can't change the original hello, so it creates a brand new string, hello, somewhere else. But, and this is the key part, the s label is still stuck to the original hello. The new hello string is just floating there with no label. If you want to use it, you have to move the label yourself. The line s equals s.upper does exactly that. It tells Python, go make that new uppercase string, and then peel off the s label from the old string and stick it onto the new one.
So the big takeaway is that all these common things you do with strings follow the exact same pattern. The plus sign doesn't add to the end of a string, it makes a totally new longer string. The star operator for repetition creates a new string. Methods like .replace or even slicing, you guessed it, they all give you a brand new string back. The original is always left completely alone.
Okay, let's look at a few common ways people get tripped up. And what you'll see is that every single one of these errors happens for the same reason, forgetting that strings are immutable. Seeing these mistakes will really help lock in that mental model.
This is the big one. We just talked about it, but it's worth seeing again. Ignoring the result. The code s.upper works perfectly. It does its job, creates a brand new string hello, and hands it back. But we didn't do anything with it. We didn't save it to a variable. We didn't print it. So it just vanishes into thin air. Meanwhile, our original s label is still pointing to hello. The fix is always to catch that new string that gets returned, usually by reassigning it, like s equals s.up. Okay, mistake number 2. Trying to change a single character using its index. This is literally trying to take a pen and write in our published book. It's a direct violation of the immutability rule, and Python will stop you with a type error. It's basically saying, nope, you can't do that. The right way, just like our book analogy, is to build a new string from the pieces. You take your new character, h, and you stick it together with a slice of the rest of the old string.
And finally, a super common type mix-up. Python is really strict about data types. To Python, the plus sign for a string means stick these together. It has no idea how to stick together a string and a number. Now, some other languages might try to guess what you mean, but that can cause some really weird bugs. Python would rather be clear. So if you try this, it'll give you a type error and basically say, hey, be specific. To fix it, you just have to explicitly turn the number into a string yourself using the star function. Then Python's perfectly happy to stick the two strings together.
So we've gone through indexing, slicing, methods, all these common pitfalls, but as you've hopefully seen, it all boils down to one single powerful idea.
And here it is. If you forget everything else from today, just remember this one thing. This is the golden rule. This one idea explains everything we've seen, why things work and why they break. It's the mental model that lets you look at code and know what it's going to do. If you can really burn this rule into your brain, you'll have mastered Python strings.
But that leaves us with a final question, right? If every tiny change creates a whole new string, doesn't that seem kind of wasteful?
I mean, what if you had a list of 1,000 names and you needed to edit all of them? Are you really creating 1,000 brand new strings in memory? Well, that apparent downside of immutability is the exact reason Python gives us other tools. And in our next explainer, we're going to look at one of those, the list, a type of sequence that is built from the ground up for data that needs to change.